Homework 17, confidence intervals for population mean, standard deviation known, video 1. It's a long title for a homework section. Before we move forward, I should let you know that normally the next homework would be confidence intervals for population mean, standard deviation unknown. I'm going to choose to skip that because it involves a new distribution besides the z distribution, and for time's sake we're just going to skip it. If you're curious about it, I recommend searching on YouTube for confidence intervals for population mean with standard deviation unknown. The procedure is identical to what we're going to see here momentarily, but there's just one change. You have to use a different distribution. Before we talk about a confidence interval, or even point estimates, I want to kind of give you an idea of what's about to happen. At the beginning of the semester, I mentioned that there are two types of statistics. There's descriptive statistics and there's inferential statistics. The purpose of descriptive statistics is to describe things. The purpose of inferential statistics is to infer things. Specifically, the goal of inferential statistics is to infer something about a population based on what you measure from a sample. The reason for inferential statistics is easy. Populations are usually either too large or too dynamic in the sense that they're changing to actually measure them accurately. However, using statistics, we can measure a sample and then claim things about a population. One thing we're going to be doing in the next two series of videos is estimating a value for a population based on what we know about a sample. And we're going to do this by building something called a confidence interval. But before we get to that, I need to define what a point estimate is. To put it simply, a point estimate is a sample statistic that estimates a population parameter. For example, at one school in a state, the mean GPA is 2.75. If we were to consider this one school within the state to be a sample of all schools in the state, then we could say, or rather the students at this one school to be a sample of all students in the state, then we could say that this 2.75 is a sample mean. In other words, x bar is equal to 2.75. But to look at it as a point estimate, we would say that x bar equals 2.75 is a point estimate for the corresponding variable for a population. Well, if this is sample mean, then that corresponding variable would be the population mean. So what we would say is, well, we don't know the mean GPA for all students in the state, but based on this one school, we could estimate it to be 2.75. How reliable is that? Not very, which is why we're going to build a confidence interval momentarily. There's another version of point estimates that we're going to be looking at, and this next example illustrates it. In one season of baseball, the home team won 53.1% of the time. We could use this if we were testing if home field advantage was actually a thing. But when we're talking about one season of baseball, we can look at that one season as a sample of all the seasons of baseball from its inception until this current day. And this 53.1% is measuring the percent of time that a particular characteristic took place. In other words, the percent of the time that a team won. Since this is the percent of the time that a sample has a characteristic, that means that this is p hat. And we'll turn it into a decimal just because I don't like writing percents equal to p hats. It's not wrong. But we normally do math with these values, and you don't do math with percents. You turn them into decimals. So p hat equals 0.531 is a point estimate for what? Well, p hat is a sample proportion, so the population parameter, the population version of it would be population proportion. So it would be a point estimate for p. So what we're saying is, because in this one season of baseball, the home team won 53.1% of the time, we're claiming that for all seasons of baseball, the home team wins 53.1% of the time. Now, I doubt very seriously that the value from this one sample would match the value for the entire population, and in fact, they rarely do. But as we move into what are called interval estimates, which we'll talk about in the next video, we're going to start with a point estimate. And by the way, the reason it's called a point estimate is actually based in geometry with a little bit of algebra. If I were to draw a number line and locate this number on it, then in terms of geometry on that line, this number is represented with a single point. So that's why it's called a point estimate, a point on a number line representing a single value. In the next video, we'll talk about how to take this point estimate and use it as the center of an interval of values to get what's called an interval estimate.